finish up your flip book with the last page. So open up to the very last page, which says quadratic equations. And up at the top it says to write the standard form of a quadratic equation. So if you're going to be graphing a quadratic equation, it's going to start with y equals ax squared plus bx plus c. That's going to help you graph it. But if you're just solving, you're going to have this same equation, the ax squared plus bx plus c, and then you're going to want to set it equal to 0. So if you're asked to solve. But basically it's the same equation. One just says y equals, and then one says equal to 0. So it just depends what you're doing with it. But basically you always want to get either the y by itself or the 0 by itself, depending what you're doing. All right? So boxes number 66 and 67, we're going to graph, bless you, we're going to graph those two quadratics. What makes them a quadratic? Remember on Friday we worked with linear equations and we drew what? Lines. With a linear equation, you draw a line. The x was to the first power, so here we've got x to the second power. Okay? That's going to make it a quadratic. That's going to change your graph. Instead of looking like a line, who knows what it's going to look like? Yes? U, we call that a fancy name, starts with a P. Anybody know what that is? Parabola. Okay, so we're going to have a parabola. Parabolas have special things like an axis of symmetry. They have a vertex. They have a domain and a range, and they have zeros. Okay, so lines, we just have two important things, right? Where they cross the y-axis and their slope. With parabolas, we've got all this other stuff. Okay, so the first thing we're going to do is we're going to find the vertex. So we use this equation, or part of the quadratic equation, which is the opposite of b over 2a. Okay? So we're going to take the number that's in front of the x term, take the opposite of it, put it over 2 times whatever is in the a position. So in this case, the b is 10, so we're going to say negative 10 over 2 times whatever's in front of the x squared. Well, it doesn't look like there's anything there, but there's really just a 1, right? So we're going to multiply times 1. 2 times 1 is 2. 2 goes into negative 10, negative 5 times. Okay, so we're going to make a little T-chart. Hopefully you've seen one of these before. And we're going to put the negative 5 in the middle, right? Because now we want a U, and that's going to be our vertex. And then we're going to do points on each side. On the left and on the right, they should match up. It has symmetry. Thank you. All right. So if we plug the negative 5 in, negative 5 squared is 25. And then 10 times negative 5 is negative 50. So 25 minus 50 would be negative 25. And then negative 25 plus 21 would be negative 4. So that's going to be our vertex. I'm going to put a little star and a V next to it. And then over here, in the little line where it says, or on the space where it asks for the vertex, I'm going to write negative 5, comma, negative 4. Our axis of symmetry, or our line of symmetry, whichever you want to call it, is going to go through that point. So it's going to be at x equals negative 5. That's the line that's going to go up and down. Yes? Are you talking about the full quadratic equation? Yes, this is only part of it. That's going to help you get the vertex. The full quadratic equation will solve it. Yes. All right. Domain on parabolas is always going to be all real numbers. And we write this fancy little R with like a double line right here. Just means all real numbers from negative infinity to positive infinity. You'll get more into that into Algebra 2 and Pre-Calculus. The range, you're always going to use the y coordinate, the y part of the coordinate. It's going to go from y greater than or equal to -4. That's because this one's going to open up. How do I know it's going to open up? Because it's positive x squared. We don't usually write a plus sign, but when it doesn't have a negative sign, we know it's positive. It's going to open up. So number 67 is going to open which way? Look at number 67. What do you see there? You see a negative sign. So that one's going to open down. Okay? So this one's going to open up because it's positive. This one's going to open down because it's negative. We'll see if there's any zeros in just a second, but let's try plugging in numbers to the right and to the left. So to the right, we're going to have -4 and -3. To the left, we'll have -6 and -7. Okay? So let's plug in -4. When we plug in -4 to x squared, we get 16. 10 times -4 is -40. So 16 minus 40 plus 21. If you punch that in your calculator, you should get -3. Now, because this is your line of symmetry in your vertex, that means that any number on either side is going to be the same. So if we got a -3 here, guess what? We're going to get a -3 there. When we graph it in just a second, you'll see what happens there. All right, now let's plug in -3. -3 squared is 9. 10 times 3 is -30. So 9 minus 30 plus 21 just so happens to be 0 and 0. So they asked us for zeros. We just got 2 of them. We got -7, 0, and we got -3, 0. Sometimes there are no zeros. Sometimes there's only 1. Just depends on the parabola. Okay, so let's graph it. We should have a point at -5, 0. So go 1, 2, 3, 4, 5 to the left and down 1, 2, 3, 4. There's our vertex. To the right, we have -4, -3. We also have -6, -3. And then we should have zeros at -3, 0. 1, 2, 3. And -7, 0. So you can see the parabola starting to form, right? She said it kind of looks like a U. Yes, it kind of looks like a U. You draw your parabola going up like this and up like this. And just like with the line, we add little arrows to show that it'll keep getting larger and larger, and it'll actually start to widen as it gets bigger and bigger. Okay? All right, box number 67. This one we already said. We know it, we recognize that it's going to open down. We want to find the x coordinate of the vertex. So we're going to take the opposite of b. So right now there's a -4, so we're going to say +4 over 2 times a, which is -2. And this simplifies to -4. So we have 4 over -4, which is just -1. All right, so let's draw our little t-chart. And about halfway down, we're going to put our -1. We're going to put 2 points to the right, which is 0 and +1. 2 points to the left, which is -2 and -3. Super easy to plug in 0, right? Because 0 squared is 0. Anything times 0 is 0. -4 times 0 is 0. 0 minus 0 is 0. 0 minus 2 is -2. Yes? Sure. All right, if we plug in -2, we're going to get the same answer because it's symmetric, right? Whatever happens on the right, it's going to happen on the left. As long as you know that this is your vertex, okay? Let's plug in +1. So if we plug in +1, 1 squared is 1. -2 times 1 is -2. -4 times 1 is -4. So we have -2 minus 4 minus 2, which ends up being -8. And if this one's -8, well, this one's also going to be -8. So we've already figured out that our axis of symmetry is going to go through that vertex. So it's going to be at x equals -1. Our vertex is did I get one? It should be 0. What happened here? Negative 1 squared is 1. 1 squared is negative 2. Did I put 0 and it should 1 and it should be 0? Let me double check it on the calculator, make sure I did it right. Negative 2 plus 4 minus 2. Yeah, it's 0, not positive 1. Sorry, I was off there, but I caught it. Okay, so the vertex is at negative 1, 0. And then, so the domain is going to be all real numbers, always is for all parabolas. The range is this number right here, the y part of our coordinate of our vertex. So it's going to be y. In this case, this parabola is opening down. So you want numbers that are less than or equal to 0. Remember up here it was greater than because this one opens up. This one's going to open down because it's negative, so it's going to be numbers less than. And let's see if there's a 0. So let's graph it. Negative 3, negative 8. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. Negative 2, negative 2. Negative 1, 0. 0. Oh, right, should be there, not there, sorry. And 1, negative 8. So it's going like this. I graphed an extra point on there. Don't need. All right. So the last question, do we have any zeros? Yes, we have one right here at negative 1, 0. So this one had 2 zeros. This one has 1 0, but you could also have no zeros, right? If this parabola had been shifted down, it wouldn't be crossing this axis at all. And then you would say there are none, or NA, not applicable. All right? Any questions on box 66 or 67? All right, so that's how you graph a parabola. Now let's talk about factoring these quadratics. So we're going to jump to box 69. And we did these the other day, but we did them without them being set equal to 0. So today, the difference is we're going to set them equal to 0, and then we're going to solve. Okay? So the first thing you're going to notice is box 69 is that right now it's set equal to 11. So you have to subtract that 11 first, and then you get x squared minus 14x plus 49 equals 0. And then we're going to factor. So you draw your two sets of parentheses for your binomial times your binomial. You take the square root of x squared, which is x and x. And then you want to figure out what two numbers multiply to get 49, but add or subtract to get negative 14. Negative 7 and negative 7, they just both happen to be the same, right? And the other day, this is where we stopped, right? But the difference is today is that it's set equal to 0, so we set them each equal to 0 separately. And this one, since they're both the same, it's a little bit easier. You just add 7, then you get x equals positive 7. Guess what you're going to get right here? Positive 7. So you get the same answer twice. You don't really have to write it twice. You don't have to say the answer is 7, and it's 7. It's kind of a little redundant, but usually you'll have two answers. Okay?